Hey guys, welcome to the revision video on transformations of functions. I'm using autograph here, and I'm going to use the equation y equals sine of x to help visualize what happens as we transform this graph. And what I'd like you to note down and really try and remember is that if we have a look at my equation down here, y equals sine bracket x close bracket, anything that happens outside of those brackets, okay, if I'm going to multiply that or add stuff to it or take stuff away or divide it, that affects what happens in our y direction. Okay, so it's either going to move up or down, or it could be stretched up or down or squashed down. That affects the y direction. But if something happens in that bracket, inside of the bracket, then that affects our x direction. So either it's going to be moving along our x-axis, or it will stretch or squash out in the on the x-axis there. So that's the main thing to remember. Okay, inside this bracket in there where our x hangs out, that affects our x direction on our graph, and outside of that bracket affects our y direction on that graph. Let's have a little look here. So I've got the equation y equals sine of x. Why don't I type in y equals sine of x, and I'm going to add 2 to it and press enter, and you see there my blue line, nothing's changed. It's not been squashed, it's not been stretched in any direction, it's just stayed exactly the same. All that's happened, it's moved from when it went through 0 here up to 1, 2, it's moved up to, as I would expect, plus 2. Let's change that. What happens if I change that plus 2 to a minus 2? To a minus 2, press enter, and it drops down to just as what we'd expect it to happen. Okay, so anything that happens, if we're adding or subtracting things outside of our brackets, that means we're going to be going up or down our y-axis. Okay. Let's pop in here, and let's change something inside our brackets. So now I can't just add 1 or 2 to my sine of x, because we're talking degrees here, and it goes up to 90, 180, 270, 360. So if I just moved it along 1, we'd barely really see it. So let's move it along, let's move it along 30, shall we? So sine of x plus 30, and I would expect it to go plus 30, wouldn't I? Plus 30 this way, but actually it's gone back, and that would be back 30 degrees if my scale read that for you, but when it said plus 30 inside of my brackets down here, it's actually gone back 30. So that might mean that if I shove a minus in here and I press enter, there we go, yeah, it's moved along to the right. And that's a theme I'd like you to pick up on. So if I'm adding or taking away stuff, that all that's happening to my function is that it is moving. If I'm adding stuff or taking away, it's moving. And if I'm adding stuff outside of the brackets, that affected our y, and it went as we expected. If we add stuff, it goes up the axis. If we took away stuff, it goes down the y-axis. Okay. However, it's not as we would expect with the x. If we add stuff to our x, we saw it went backwards, and if we took away stuff, it actually goes forwards. So, and that's a theme that happens also when it comes to multiplying and dividing in just a second. That y happens as we expect. Okay. If we expect it to be plus, then it will go up. If it's expecting it to be taken away, then it will go down. X is the exact opposite. Great, so that's adding and subtracting in and outside the brackets. So we can see how we can move our function about. And I could do a couple of things. I could do sine of x, and we'll take away 100. So we'll move it along to the right 100 in my x direction, and I'll move it up 3, not 4, 3 in my y direction, and suddenly it's been moved along and up, and I can do multiple things at once. Okay, great, let me delete this. Yes, I do like to delete this. So let's have a look at what happens when we multiply. So if I hit a new equation, at the moment I've got y equals sine of x hanging out in there. Now I'm going to first show us what happens when we multiply outside of our brackets. So if I hit times by 2, okay, times it by 2, what happens there is it's not been moved at all. You can see it goes through 0 here, it still goes through at 0, it goes through exactly the same point, 0, 180, 360. So it's not been moved at all. But what actually happens is it's been stretched, it's been made bigger, and it's been made bigger in the y direction, as I mentioned earlier. If it happens outside of our brackets, it affects the y. And when I times something by 2, I'd expect that something to get bigger, because I'm doubling it. And that's what's happened here. Where originally it went all the way up to 1, it now goes up to 2. And where originally it went down to minus 1, it now goes down to minus 2. So what happens if I times it by 3? Would I expect that to stretch up to 3? Yeah, it does. There we go. It stretches up to 3 and down to 3. So it happens as I expect. However, if I times it by something that's less than 1, so I times it by a half, let's say, suddenly I've squashed it. So instead of it going up to 1 up here, it's been squashed, it only goes up to a half and down to minus half here. And it doesn't let me move at all. So if we're multiplying our function outside of the brackets, it affects how we're stretching it in our y-axis. And if we're multiplying it by something that is bigger than 1, it will actually stretch it to make it look bigger. And if we're multiplying by a decimal that's smaller than 1, it will actually squash it down. Okay, so what happens if I take that timesing and I shove it inside x times by 2 in my x inside the bracket? It's going to affect my x direction, and as you may observe there, it's been squashed. And that's so it happens against what we'd expect. So with my x-axis, I'd expect if I'm timesing something by 2, that it'd be made twice as big. It would be stretched out to be twice as big. But actually, the opposite happens when we're talking about our x direction, and it's been squashed down. So originally, looking at our red curve, it goes up to 1 and it comes down to 180. But now, because it's been squashed by a factor of 2. It's times by 2. So in fact, it's done the opposite effect, and it's halved it. So it goes up our blue line, it comes down to 90 and goes up. So that's how a multiplication affects our x. And if I double click on that, let's times it by 3. Let's make it 3 times squashed. Or if let's push the bit out here, let's squash it 10 times. What's going to happen here? Goodness me. Alright, and what happens if I change that to be a decimal that's smaller than 1? So like on my x-axis, if I times it by a decimal that's smaller than 1, what happened is it actually did the opposite and made it sorry, on my y-axis it made it smaller as I would expect, but on my x-axis I'm expecting the exact opposite. And there we go. I've times it by a half, and instead of squashing it, making it half as big, it's actually stretched out to make it twice as big. So there we have it. Okay, that's pretty much everything you need to know. Let me just finally, I'm just going to add a little pop it in here. What I'm going to do is I'm going to squash my x-axis to make it 4 times smaller. So I'm going to squash my x-axis by 4, but then I'm going to stretch it in my y-axis by 4. Let's do it by 4 because 5 will go off my scale. Okay. So if I'm timesing my x inside the brackets by 4, it's actually going to squash it. So in my x direction, along here, it's going to get 4 times smaller. So instead of going up and down at 180, it will actually go up and down at a quarter of 180, which would be 45. So I'd expect it to go up and down here, and then back through here, and then up, etc. Let's have a look and see if that actually happens. Oh dear, what has happened to that? Times it by 4, I've squashed it by 4. Oh, I shouldn't write x4, I need to write a times, a different sort of time, so my computer doesn't understand how I want to times. There we go. Okay, so it's actually happened 4 times between 0 and 180. Instead of just being one kind of hump, we've had a hump, a down hump, an up hump, and a down hump between 0 and 180, which is what I expected. And in my y-axis, instead of it stopping and going up to 1, it now goes all the way up to 4 and then comes all the way back down. So guys, I hope that was helpful, and I advise you to have a little play around with that. And I really hope it helps you in your revision for your GCSE. This is an A, sort of A star grade topic to play around with this. I'll see you later.